So our next speaker is Paul Hoffman, also from the Office of the CTO from ICANN. He will talk about, he will introduce you guys to the OCTO Research Middlebox Lab. Since we're a little bit ahead of time, you get 3 minutes additional. Thank you.
Okay, so hi, and I won't sit quite so close. So much of what you've seen already today of work that we're doing in ICANN is measurements over the net, watching recursive resolvers live and such like that. One of the things that we've dealt with in the real world is the fact that there are these hardware things that are close to the end users, often middle boxes. Either they're sitting in an end user's house or a company or whatever, and those can have an effect on the DNS. So we decided we should start looking at these and see what they're doing. So that's what I will talk about today. Am I the only? Oh, so briefly, what we have in the lab, we have at this point just a few dozen middle boxes. We can have more. There's always more middle boxes to be had. Of these, so some of you might be familiar with the fact that in the past there have been some measurements done on SOHO routers, some academic work on do the SOHO routers work, do they block this or that, but almost none has been done on enterprise-grade firewalls and routers. And yet, as you'll see in another slide, those sort of suck too, but in a completely different way. So we actually are having all of them in the lab. It's not just the SOHO routers. We are looking sort of at everything that might be a middle box that could be getting in the way. We also have a workstation running VMware so that we can spin up VMs of sort of any sort, either to be firewalls, because today if you go out as an enterprise and walk up to a checkpoint or whomever and say, I want a firewall, they might offer you a VM firewall. That is, that you don't actually walk out of there with a box. It might be a license number and such like that. So we're able to run those as well. Also in the lab, of course, there's systems for running the tests, which are mostly on the VMware workstation, so that we can generate interesting traffic. And yeah, there's a lot of cables. That is, for each SOHO firewall, you have to have 2 cables. So I don't have a picture of the lab here, but if you did, you would see like a solid sheet of white cables. So we had a couple reasons why we wanted to start the Middlebox lab, and hopefully when I'm done with this you'll actually have more reasons for me. We care about how these devices affect the DNS. We know from some of the earlier academic research, certainly on the SOHO firewalls, that some of them block various types of resolution for no good reason. And when I say for no good reason, I mean some implementer read part of a document, or even worse, read a document and some answer on SourceForge or whatever, and said, oh, this is what I'm supposed to do, and it just didn't work. We know that they also act as proxies, and sometimes silently, and sometimes not really in a good way. That is, that a developer of a middle box, most of the time, especially for inexpensive boxes, their goal is to reduce all possible service calls. That really is their goal. I mean, their number one goal is to sell the box, but their number 2 goal is to prevent service calls. And so some of them decided, oh, well, a way to prevent service calls for DNS traffic is to don't answer it, pass it through, and they might do that badly. But we're also really concerned about some of the choices that they might have made, even currently, that will affect future development that we want to do. So we want to start cataloging some of that. We want to find similarities in them. So one thing that we do know is that most vendors of inexpensive boxes use a handful of OEMs, although the list of OEMs changes over time. So we would like to find some commonality among them, especially if we do find a particular OEM doing a bad job, we might go talk to them. But even the vendors that do their own work, such as the Ciscos and Junipers and such like that, Juniper has two very different lines of firewalls, which you can't really tell because they're all 2 letters and 4 digits kind of thing. But they actually have different back ends. And so it is interesting to find some commonality there as well. But we're also, one of the reasons we set up the Middlebox Lab was not only for DNS and not only for ICANN. We want to be helpful to the general internet population because they all use the DNS, and the DNS is going to run over other things in the future. So there's a bunch of other organizations that are looking at things, especially transports. Some of these transports are going to be running DNS in the future. So it'd be nice to know if some of those transports are blocked or otherwise grafrobbled by some of the middle boxes. And because now we're getting more activity of running DNS over TLS, some of the middle boxes intercept TLS. Some of them do that really badly. Some of them do it sort of scarily well. You know, we sort of want to be able to see them and we can't. So being able to identify that is definitely one of our goals. And we have a bunch of non-goals. We are not going to do name and shame. There's other people who like to do name and shame. We're not in that group. We might go talk to a vendor if we can find them and say, hey, we think this is happening. We would love to show them data. We would love to show them data that they can reproduce easily. And we can say, maybe try to do that better, but there's definitely no name and shame in this, at least from us. We're not going to do conformance testing. Conformance testing is hard. Conformance testing the DNS it would take another 20 years to agree on the conformance tests, and no one's asking us to do that. You know, people want it to happen, but that's not a goal for this. And we don't want to be able to say, oh, well, you know, certain percentage of the boxes do this. There's no way we can extrapolate from the fact that we own a box through its sales, like even if we knew how many sales it was, to be able to say how much of the internet is affected by this box. For one thing, a lot of people throw the boxes away. So the fact that this box has sold 1 million copies is actually somewhat irrelevant. For those of you who work for cable operators, you'll know this, that you have shipped multiple boxes to my parents. I don't actually have cable. My parents do. They have, you know, so you can't count the boxes. You can only count their current box. And we're not trying to collect every possible kind of middle box. For example, we do have the ability to do cable boxes, which has a completely different back end, and you have to learn this whole other layer too. It's really a nightmare. We're not going to try to collect all of those because, in fact, in the cable world, a lot of those middle boxes are proprietary. So it wouldn't matter if we could actually hook them into the lab. We wouldn't get any data out of them because we are not the cable operator. We're not priming them the way they want. So we're really not trying to do that. So these are our non-goals. And in setting up the lab, you know, we found some really low-hanging fruit on problems. A lot of firewalls have really, really questionable default values. When I say questionable, I mean even beyond the blocking TCP on port 53, because they might have read a document somewhere or whatever. There are some other really bad ones. Blocking port 853, which essentially means blocking every port that they don't know about. Port 853, for those of you who aren't aware, is for doing DNS over TLS. New standards, it's been out for a year or two. Sarah? 2 years? 1 year? I actually forget. 1 year. Yeah. So they wouldn't have known about it, but there's no reason for them to have blocked port 853. But this has an effect on us being able to deploy good, secure DNS from the house. And generally for the SOHO routers, there's absolutely nothing in the document. They have GUI interfaces, but there's nothing in the documentation that says how to make that interface work or even how to get there. A lot of them have CLI interfaces, which is why we're getting, you know, massive attacks. Is no one knows that it's there, but there's an open port on the outside for it. So we're finding these things just in setting up, you know, once you set up your fourth middle box, you start going, oh, let's look at this. Oh, yeah, that one's doing it too, that kind of thing. We're also finding a lot of SOHO routers that, in fact, do DNS forwarding. So there's nothing on the box or anything that says, how do I handle your DNS? And you're used to, your last box just went to your ISP. This box is not. They might be sending everything to 8888. They might be sending everything to a recursive resolver that they control so they can watch your DNS track. There's all sorts of things that might happen. We're finding it. The worst one that I have found, quite frankly, is we started off doing this saying, oh, we bought this box from Amazon. It might have been there for a couple of months. We should do a firmware upgrade and then brick the box. And, you call them up and they go like, oh, yeah. You went to 1.0.4.8, right? Yeah. Send us back the box and we'll send you. And it's like, no, I spent $25 on this box. I'm not going to spend $30 sending you the box back. So that actually is sort of common, and it is one of, the effect of this is it's one of the reasons why you don't just tell every user, always update the firmware on your Soho router. Because if you do, you are causing yourself a lot of tech support problems because a fair number of them actually get bricked. So let me talk a little bit about some of the research topics we want to do. I believe at this point, because we actually have checked this, do any of the middle boxes do DNSSEC validation by default? No, except for the nerd boxes that are, that say we do DNSSEC validation by default. Basically even even an enterprise level router, they do not turn on DNSSEC validation. But a better question is also, especially for the enterprise ones, the ones that have a real UI that we can find, do they make it easy to turn on DNSSEC? So this is not, even though we have the box in the lab, a bit of research we can do is we also have all the manuals in the lab, and we can see if the manuals are correct. Go through and see what would it take to turn on DNSSEC. That's something we want to do. EDNS checking, something that since a lot of the future of the DNS relies on EDNS extensions, do they handle EDNS extensions correctly? Do they handle IPv6 correctly, especially fragmentation? Now we're getting into the realm where if you were employed by an OEM vendor to write generic software and you were supposed to have it done last week and it was supposed to cost 1 cent, how much would you have put in? And someone said, well, you have to do IPv6. Maybe all you do is recognize IPv6 addresses. Maybe you do this right. Maybe you pulled in some random library. So we would like to actually sort of get a feeling for how well is that done. Do they forward, and if so, do they forward do all of them forward to Google? One of the questions that is important to us is, can they support transports other than UDP and TCP? And this is because we expect DNS to be running over things like QUIC in the future. So if QUIC is blocked by a significant number of, say, enterprise routers, which means we're going to have to talk to people, that's actually valuable information. So we want to hear from you folks on what we should be testing. It's fairly easy for us to test, especially if some of the tests are not run these packets through, although we can run sort of any packets through them and see what happens. It would be interesting to hear from you about things like, can this be configured and such like that. So we also have a lot of the VMs, like I said, and we have all the distributions, we've got Windows, all of that. For the upcoming KSK rollover, we actually ran a test. We pretty much booted up almost every interesting distro from the last couple of years and see what they did, see what they did starting up. Some of them don't even have DNS resolvers in them, but the ones that did, what did they do? So what we found is actually almost no distributions act as recursive resolvers from the get-go. Some do, only 2. And of those 2, neither of them were doing DNSSEC. So what that said to us is we didn't need to reach out to anybody running a random distro about the KSK rollover because they needed to have at least turned on something. Now, they may not have known what they had turned on, but if they're just running a random distro, no, we didn't have to worry about them running a DNSSEC validator that was going to come back and bite us. So we're going to perform similar tests and such like that on these VMs as well. We can spin up as many of them as we need because VMs are cheap. So we have a bunch of future ideas on this as well. One of the things that's actually fairly important for us is the idea of how do any normal recursive resolver pick the authoritative servers to talk to. So there was a report on this from VeriSign about 5 years ago, which Matt Larson, my boss, was co-author on, and they didn't keep their test bed. So I'm going to recreate all of, the work. A lot of you have seen that work because it did actually show some surprising results on how various versions of like Unbound and Bind sort of get locked into a way of picking their upstream that seemed a little bit odd. So we will rerun that, and we will rerun it in a way where everyone who doesn't like our results can actually test as well. So, all of that, we will have either the Puppet scripts or however we end up doing that, we will put that out there. We want to see how they handle new DNSSEC algorithms, because at some point, there is going to probably be a algorithm role for the KSK. It'd be nice to know ahead of time for, every distro we can get, every copy of every, resolver software we can get. How does it handle algorithm upgrades? Are there resolvers that only do TCP? If we tell resolvers to only do TCP, does that work? An interesting question. And so, so things like this. We want to model the IPv6 behaviors as well. So that's it for what I've done, but I want to emphasize this is not just us doing this research. A lot of the ideas on the previous slides actually came from folks like you. So anything that you have on ideas for how we can, what we can be testing and such like that, we're very open. We can either do it right now here at the mic, certainly grab me at various meetings. We have question and answer at the end. But given a lab of Middleboxes, if this was your lab, what would you want me to be testing? So, please.
Unfortunately, this is a non-technical question.
That's fine. That's fine.
I've noted three key things that you said. One is on your last slide in terms of how to handle DNSSEC algorithm. Mm-hmm. And you said earlier that you can't really tell, sometimes you can't identify the vendor.
Right.
And the last thing that I noted was you said there's no true way to measure the impact overall.
Yeah.
So based on your research, is there any minimum specifications that you can actually develop as a best practice guide that persons who do purchase these servers should actually be looking for in the specs to ensure that they can, one, handle the some of the protocols that are coming out and the IPv4, IPv6 fragmentation?
There probably are best current practices that we can do. We haven't done that, but I think as an outcome of us looking at some of these that definitely aren't doing, like if I said, of the couple dozen I had in the lab, 5 of them don't do X. The number of groans in this room would indicate that should have been on the best practice and stuff. So yes, we could use this as a way of generating best. We don't need to generate best practices for something that everyone already does, but I think you're right. We could use this as a base for that.
Is it within your mandate to be able to produce that? It is.
Absolutely. Thank you.
Rubens Q, NICTAC PR. Have you noticed that a lot on large number of Soho routers end up generating queries to undelegated TLDs with their vendor name?
I haven't looked, but thank you. I hadn't thought of that, and that's a very easy thing to do. I mean, we are looking at the traffic on them. No, I haven't. Yes, I will. And it would be interesting to see which ones those are. Now, I note that, again, I don't have all of the cable boxes, and I know that some of those are the ones that generate them, like .box, I believe, is from a cable vendor. Mm-hmm. So yes, it would be interesting to have a list of those, of the ones that just come out saying Linksys or D-Link or any of the others.
Although you said you won't name and shame, I will.
Sure.
This is the one that we see generating queries in the L-Hood server.
Yep.
Belkin, D-Link, Home Station, D-Link Router, Davolink, Blink AP, IP Time, TotalLink, and PK 5001.
So unfortunately, you just mentioned a bunch of vendors who I don't have even a single box of in the Middlebox lab. So I want to talk to you afterwards, if nothing else, to get that list so that I go out and find at least one Middlebox from those. It's a very interesting question. So yes, thank you. Yeah, and yes, I do definitely want your list.
Before we go on, let me add to that on the receiving side, in the root server traffic,
yeah.
We see indeed a lot of the strings that you just mentioned. I would love to get that list from you.
Yeah, right, right, yeah.
So I was thinking to myself, and joking in my own head, what about hotel Wi-Fi? What about hotspots? What about Starbucks? I realized that it would be impractical to get all of that infrastructure into your own lab.
Yes.
But have you considered how to apply some of this to be able to validate? Because the impact to end users of misimplementations in those environments is obviously going to be significant.
Correct, correct. So yes, we have thought about that as a long-term thing. One thing that we can do, so Jeff Houston, as you know, sends out queries from random places just because someone looked at a Google ad. We could possibly do better than that. We can possibly put clients in various places and try to know something about it, like this client did this at this time, and oh my God, it did something we don't like, and actually have a way of getting back to them and say, where were you at 10:43 today? And if someone says, I was at a Starbucks, we'd go like, okay, now we have a new area of research. So yes, we've thought about it. We haven't moved forwards on that. But it would be wonderful if, especially some of those, and let's just use Starbucks as an example, if Starbucks has somewhat standardized on the router that they use, we would love to have one of those in the lab. And I will do whatever it takes to make that implementable in the lab.
As a follow-up, I was going to ask, are there any industry groups that you're aware of that you could be working with along those lines?
Yes, and in fact, some of the vendors have said that they will give us old boxes that can run Rev 4 through 7, even though they're currently on 25. Unfortunately,
no, that's important.
Right,
That's
going
really
from
important.
4 to 7 usually means you can't go back to 4. But they also have a lot of old boxes. So yeah, so we are definitely looking. I don't want to become an eBay expert, but I might have to on this. So yeah.
Thank you.
Yeah.
Before we go on, I'm going to cut the line after Steve Crocker.
Yep.
Can we have short answers, please?
Yeah, please.
Thank you.
Yeah.
Okay, thank you, Paul. David from BI, and I think it's very important, and I think you and me and working on the DNS over HTTP is one purpose is to go across the Middlebox. My question is, what's the expectation of your work? A list of the old box or some cases of failure, or I mean it's very hard to coordinate different group of people. For example, the IP layer, TCP layer, or the vendors, the devices. Vendors. So I would like to know what.
Right. So we're not trying to do conformance testing or name and shame. However, we can inform the community that we see in our non-scientific sample a lot of boxes that do this, or in our non-scientific sample we didn't see anything that blocked this. So that's the kind of information we expect to be putting out.
Okay.
Yeah.
Thank you.
Matt Poundstead from Rightside. I have an idea for you. At any TLD authoritative server, there's sort of this constant background radiation of queries for names that are not only not delegated to that server, but have never been delegated to that server. And as far as I know, that's never been satisfactorily explained, and I'd be curious if there's anything in your lab that does that.
Right. And so yes, thank you, and do send that to me so I remember it. But that's exactly one of the things we want to be able to do. And it may not come from the hardware, by the way. That could be from a distro that somebody put together wrong. We would love to find that as well.
Steve Crocker, I can. This is great work. I love this. I'm reminded of a question that we asked in SAC a while ago. I'll give you the reference in a minute. The question that we asked was, with respect to IPv6, if you were running a network in an enterprise, would you be able to transition to IPv6 and do the same network management and security control? So we did a survey of available products and compared their feature set for IPv4 versus IPv6, and discovered that even the same box from the same vendor running in IPv6 mode did not have all the same features. I'm not 100% sure whether or not you're in a position to do similar kinds of testing or comparison, but you have an awful lot of stuff that might enable that. The report, just for reference, from a long time ago is almost 10 years ago, October 2007, and it's SAC report, SAC 021, I think.
Mm-hmm. Yeah, so we aren't in a position to do anything definitive on that,
Yeah.
but we can certainly, again, one of the things I want to be able to do out of the lab is to, if somebody says, Juniper Box X can't do this, and I can actually have Juniper Box X doing it, to say, the way I set it up was I went through this step, and this step, is that how you did it? And come up with the same answers. And we would love to publish things like that. So,
All right.
yeah.
Good.
Thanks.
Thank you, Paul.